In this video, we're going to solve a problem taken from AIME 2014. To solve the equation that the sum of the fractions 3 over x minus 3, 5 over x minus 5, 17 over x minus 17, and 19 over x minus 19 equals x squared minus 11x minus 4. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. One thing that's interesting on the four fractions at the left side is that if we add 1 to each of them, then they will have the same numerator, which is x. So, for example, if I add x minus 3 here, then the sum is actually x, and if I add x minus 5 at the top, which is actually adding 1 into the whole fraction, then again are the same numerator. So another thing is that there are four fractions here, so if I'm doing this thing, I'm actually adding 4 on this side. And so for the equation as a whole, I have to add 4 at the right as well. Then we can even cancel out this term. So if I add 4 on both sides, it will actually get x over x minus 3 plus x over x minus 5 plus x over x minus 17 plus x over x minus 19, and the sum is equal to x squared minus 11x. And from this we can see that x equals 0 is clearly a solution, and for other cases then I can divide both sides by x. So I say x equals 0, or 1 over x minus 3 plus 1 over x minus 5 plus 1 over x minus 17 plus 1 over x minus 19, and the sum is equal to x minus 11. So then the equation starts to become simpler. Then to simplify left hand side further, I'm going to add fractions in this way. I'm going to group these two terms together and these two terms together, the yellow group and the green group. So for the yellow group, the sum is, for the top we have 2x minus 22, and for the denominator we have x minus 3 times x minus 19, while for the green group we have the same numerator. That's the reason I chose to add the fractions in this way. And somehow, for 2x minus 22 as the numerator of both fractions on the left, it's actually a multiple of the expression at the right, x minus 11. So I can further say that x equals 11, or I can divide both sides by x minus 11, and I'll have 2 over x minus 3 times x minus 19 plus 2 over x minus 5 times x minus 17, and that equals 1. Now at this point, to further simplify the fraction, as in just to write it in fewer letters, I'm going to let u equals x minus 11, because you may notice that for these four expressions, x minus 3, minus 19, minus 5, minus 17, there's actually some kind of a midpoint, a number at the middle, which is x minus 11. So if I let u to be this number, I can make the expression at the left more symmetric. Then the equation becomes two over u plus 8. So if u is x minus 11, then x minus 3 equals u plus 8, x minus 19 equals u minus 8, so 1 plus 1 minus, as you can see. X minus 5 is u plus 6, while x minus 17 is u minus 6. Again, is 1 plus 1 minus. And after the expansion, it's again a very simple expression because it's just difference of squares. And now we can add. And I have u squared minus 64 times u squared minus 36. So then further simplify. For 64 times 36 is actually 8 squared times 6 squared, so it's 48 squared, 2304. So now we somehow have a quadratic about u squared. And then to solve it, I'm going to use the quadratic formula. So I don't have to guess numbers while I do factorization. And for the number inside the square root is actually 104 squared is 10816 minus 10,016. So it's actually 800. Smaller third sign. Simplify the third, and you have 52 plus or minus 10 times root 2. So this is u squared. So that means u is the square root of this. It can be plus, it can be minus. And so we still have valid solutions because 10 times root 2 is far smaller than 52. So even I subtract the 52 by this third, it's still positive. So the solutions are valid. Now we have 4 solutions on u, and finally because x equals, as we can see here, u equals x minus 11. So to solve for x, I just add 11 on all of these solutions. So x can be 11 plus the square root minus the square root, or the third inside is actually minus and then again at the outside I'm going to do plus or minus. And of course, including the solutions 0 or 11, now we have 6 solutions. And if we go back to the top of our problem, you can see that we're actually having a degree 6 equation. If I kind of multiply everything, like add up all denominators on the left over here, I'll have a degree 4 polynomial at the bottom, and I move it to the right, I have degree 6. So I actually expect 6 solutions. And if I scroll down again, you'll see that indeed I have 6 solutions. So these are all valid, and it's our final answer. Please share your ideas in the comments. Thank you for watching. See you next time.